Hey everyone, welcome back to the channel. My name is Patrick with Denali Racing and Performance. This video is going to be about billet main caps for an LS. I'm going to kind of do a quick walkthrough of where I'm at right now with these main caps. I did already cut them out in their general form, general shape. Nothing too exciting, but we have some going on the CNC machine right now, getting the holes and notches drilled in for the main bearing, as well as the dowel pin holes. So I'll do a quick walkthrough on where I'm at now and basically what we're looking at and how we got to this point. This is a 2013 LC9. And what we're going to be doing is keeping it a factory bore. We're actually going 5 thou over, and we could do that in a hone. I wound up getting a Manley billet crank. So it's a stock LS stroke, well, meaning it's a 3-inch 622 thou stroke. So stock 5.3 stroke. That's again a Manley billet center counterweight crank. I got it over there. I'm not going to pull it out. It's too humid in here right now. We don't have air conditioning. It's not terrible in here, but it is about 102 degrees out here in New Jersey. So it can get pretty miserable in here. So I'm going to leave it in its box, but take my word for it. We also got the Cali's Ultra connecting rod for it, not the Enforcer, the one underneath that. That's a 6-inch 125 thou rod. And the pistons, not too certain yet where I'm going with that. To be honest with you, we're probably going to go with the Summit Pro LS piston. It's a really nice piston. All the features that they incorporate in it and the manufacturing of it is pretty reasonable versus like a Waseco Red, or you could also step up to a Manley Standard Series or Extreme Duty Series piston. That's pretty much the same. I'm not too certain yet. We have a lot of good internal parts, meaning the crank and the connecting rods. So right now, I think that's where I'm leaning. I want something that's kind of shelvable, where if we do break a piston or something happens, it's a little bit easier to get, whereas the Summit Pro LS piston is stocked all the time at Summit. So still debating that, probably what I'm going to go with. You can roast me in the comments if you think that's kind of a cheap way, but again, it's about a $700 set of pistons versus an $800 set of pistons from Manley on a standard duty and a $1,000 set of pistons from Manley on the extreme duty. There are some differences, but in reality, with the Manley Standard and Extreme Duty, it's more on the pin side. So we could debate that when it comes to the LS piston, but again, I'm pretty confident with a thicker wall on that pin, we should be okay. So right now, with the billet LS main caps, they're machined out of aluminum. So I have one here. I laser engraved them with an arrow. This is number 1 cap. This was just profiled out. So we have our final dimension here on the skirt and our final dimension here on the block itself, on the registers for the main cap. We are about 3.5 thou big on the bore here. And that's kind of relative because when we mic this block, we're checking the radius, so the block side main bearing sitting into it all the way at the bottom to the mating surface of the cap on the block side, and we're actually 5 thou bigger. So we're technically 8.5 thou bigger here. Just so happens that's how it was machined from the factory. We're not going to try to deck the block mating surface here. We're just going to go with it, align hone it. But technically it is 5 thou closer to the cam center line than you typically would see. But again, that's all relative. The cam technically would have been machined after, or the final bore would have been machined after, so it technically is in line. But right now, we're going to leave it the way it is with our extra material here. And that can happen because the main caps, being the powdered metal, kind of pushes the align hone down into the aluminum a little bit easier. So now we have these aluminum ones here. Very standard design. We actually have a bigger radius here in the corner, a little bit thicker material here around the 6-bolt surfaces. And we also added this 200 thou, 250 thou tall hump, which puts this about level of the pan rail. Right now, again, I have my thrust cap in the CNC machine. It just got done. I'm going to bring the camera over there, show you guys what that looks like. We did a pre-drill. Again, we are notching for the main bearing. We are doing our bores for the pins, running a 201 pin. We're not running a hardened pin. We're running a more of a softer 1018, 1008 steel pin. You don't want it to be a hard pin. It could crack. And then again, we're also doing the bores for the bolts. So we have a standard set of ARP hardware that just came in. So we're getting ready now. Obviously, we're going to start drilling our holes, getting everything ready to go to get this off to the machine shop. I don't have an align hone. I just have CNC machines, and they're going to align hone it, and then we can move on to the next steps. This block is in really nice condition. Again, it's a 2013 LC9. If you don't know, the exposed bore or sleeve in the deck surface is 218 thou, give or take. Yours may vary, but it's extremely thick. There are a couple people out there right now, well, mainly one person, who's been running really fast on a stock bore. He's actually 20 thou over, but stock sleeve LC9 block. So that's what we're going to do, but we're not going to be pushing those numbers. Our weight is going to be a little bit higher than what he is running, so we're not going to twist this block up too bad. But we do, again, have a lot of good internal parts for it, and we're confident it's going to stay together. I am entered into Hot Rod Drag Week, again, which is coming up here in September, so there is a crunch time to it. I've been just getting into the engine to get it ready to go. We have the majority of the parts, just waiting to get some heads for it. As you can see in the background here, we have my 2007 GMC Envoy Denali that I named Denial, and it had a couple iterations, being a standard 850 car for drag and drives. Then it went to an all-wheel drive, where I kind of redid a whole lot of stuff. I'll have a video out of more in-depth, a long-form video with my co-driver. Happens to be my cousin. He's going to be co-driving with me this year for Hot Rod Drag Week, and then hopefully if we get into Sick Week in Florida for 2026. But I'm going to come out with a long-form video of the progress on that. But basically, it's been gutted, sheet metal floor, 25.5 chassis, but it's all chrome ollie. And I debate why didn't I go 25.3. Well, where the cage was at the time, being a chrome ollie 850, I didn't really want to get too much into it. And I probably could later on, but right now, the speed that I wanted to achieve and the time I want to achieve is fine. I'm entered into the modified class for Hot Rod Drag Week. And the car that ran the average last year was like a 723. I'm not going to come close to that because I'd have to push this pretty hard. And I don't want to do that. I want this to be fun. I want it to be consistent. I want it to be reliable. And so that's where I'm at. And eventually we can start playing with things there. Again, tube chassis, fabricated 9-inch 4-link, tin soldiers, no prep brackets, 4-link brackets. We have a Cameron Johnson CJRC, average Johnson anti-roll bar. A couple things in the back. Again, you'll see a long-form video of it. We have a twin turbo from FIS. They've been gracious enough to sponsor us with those two turbos, including Brian Tooley Racing, sponsor us with an intake, valve covers, and fuel rails. So we have that. Again, thank you to those guys for believing in us and helping us get closer and closer to our goal of getting this going as soon as possible. So, has a funny car cage, removable steering wheel, all the things you would typically see in a higher-end car. All the sheet metal we're doing, tubs. It has a Bogart 14-inch wide wheels. We're going to trim down about 13 and do a double beadlock. And so we're just waiting on a few things, doing some changing to some of the things to take it away from being all-wheel drive. But again, I've said a lot, but there'll be a much long form and kind of interview with myself and my cousin, who's going to be my co-driver, coming up here in September. But we have these main caps, and I'll kind of walk them up to the camera so you can see them. Okay, this height here, again, this height here is what it should be. I forgot what the number is. The skirt dimension here, the width there, and the width here for the block register. Okay, we added material here. Now, this was just, these were very simply cut out, all the same. Most of the caps are 920 thou wide, so 0.92. The thrust cap is actually a little bit narrower, in some cases 904, but we all made them 920 thou. And then they're going to individually go back into the CNC machine in a fixture or in a setup in a way that we can start doing all the other work and drilling the holes and doing everything preparation-wise. So again, we are technically 8.5 thou heavy for this cap, and they'll be able to align hone that out without having to line bore it. So that's the hope. But we should be okay there. With this, with the thrust was pretty simple to do by calculating what we needed to do to be able to relieve the cap for the thrust. So they all are the same, and they were all made out of 6061 with the grain structure going this way, the longitude of the cap for strength. Some people, you can anodize these for a little bit harder surface. I don't believe we need to do that. These are pretty stout as is. And again, they were just cut out of a piece of 1.25" plate, Kaiser US mill, and with the grain structure the way they were. So I'll grab the other ones. They're pretty much all the same. All right, and again, I went ahead and laser engraved them with an arrow and their designation number so that there's no confusion. But these are all the same here. Obviously, the thrust cap is going to be a little bit different. But what we'll do is I'll grab your camera, we'll go over, see what it looks like in the machine. All right, I have machine blocks down here on the bottom to kind of support it. So it sits in my vise with a block here pushing against it. All right, we have a rough bore here, actually rough drilled bore there, and then I'll run a longer 3 flute 3/8 end mill very slowly down to finish the bores there. So everything else looks pretty good. And we've been indicating them off this thrust surface here as it stepped down, and on the register surface here, and indicating them in so they're nice and flat. So everything looks pretty good there. Again, we're going to rough bore them. We have our bores here, which have the pin check. Okay, and then we also have our notch in there for our main bearing to sit into, so we can spin or move. So it's coming out pretty good. I'm going to check those. I'm going to run the program again to actually do a bore on those. I'll get a little footage of that too. So we got the main caps all done. We have them installed here. One of the last things to do is kind of start pinning them in. It may not be the greatest video of showing all the machining of this, but I promise you with some of the quick little clips that I have put in there, it's just very basic. It's not that difficult. There are a few things to look out for when doing this, okay? Yes, I have a machine shop. I have CNC machines, but I don't have engine machining capabilities as where I have to do an align hone on the main tunnel here. The biggest thing is I have a big surface plate with an indicator, the whole metrology kind of setup, and I had put this block on my granite plate and leveled it off, and then came in and indicated at the bottom of the main webbing on the block itself. Okay, I zeroed that out on my indicator. I have a Michitoyu 18-inch indicator with the Michitoyu 10 dial indicator. In zeroing that out, I then come up to a clean surface on the split of the main webbing. When I get that measurement, I got 1 inch, 381 thou. If you multiply that by 2, you get 2 inch, 762 thou. Now, that works, okay, fine. The factory bore for the main tunnel is 2 inch, 751 thou. So we're about 11 thou heavy. Divide that by 2, right? So we're about 5 thou down in where we're supposed to be. We don't know which one is which. It really doesn't matter at this point. In making the cap, I had to then calculate that. So again, we added overall that difference to bring it down to 2 inch, 751 thou. Now we're going to go over that, but leaving the machine shop to align hone it plenty of material. Now I had left about 3.5 to 4 thou of material on our aluminum cap for that to happen, but that's left with whatever we have oversized technically on the main tunnel on the block itself. So at the end of the day, that gives us 3.5 thou to 4 thou over standard 2 inch, 751 thou bore for the main tunnel. So that's a couple things you do have to look out for, giving enough material. And in that, you could, if you buy any aftermarket caps, they're usually like 10, 15 thou under for that reason. But the problem with that is time and money for me to have. I don't necessarily have the capability to line bore the main tunnel, and I don't want to. If I do some math, then I'm able to calculate what I need and what I can leave. And talking with the local machine shop, 3.5 to 4 thou is perfect for an aluminum cap, aluminum block. So they're happy with that. The next step is pinning it. So when we machined our caps, again, there's no voodoo, there's no mysterious magic in this. All the caps were machined out of 1.25" plate. The grain structure was flowing in this direction. And these, again, are 920 thou thick. A little bit bigger than the factory, about 8.5 thou bigger, but from the factory cap, but the main webbing in the block is approximately that size. And we're not running into any clearance issues with the counterweights in the crank. So with that being said, again, we machined them very generically. This dimension here is a little bit on the tighter side than a typical powder metal cap from the factory, but not to the point where we're trying to force the skirt out of the block. Same with the register here, okay? It wound up being perfect for the tolerance that I wanted versus GM's tolerance on a steel cap to an aluminum block. So that's subjective in my opinion, whatever you choose to do. Obviously, this is a higher skill level in CNC machining, and I feel that the corrections I made and the steps that I did are sufficient enough, more than sufficient enough, to be able to have a successful main cap for this engine. Now, again, you'll see in the clips we're kind of drilling down. We're doing some pilot boring. I'll bring it in here. You'll see. So make sure we're in a good shot here. Okay, we have our pins. Focus here. Okay. We have our pins. The pin press for the cap is tighter on the pin, and on the tighter side of the tolerance on the cap, and on the looser side of the tolerance on the block. This is a 201 pin, and the cool thing about doing that is, all right, so we did it here. We're indicating off the register. I'm indicating this being my work corner offset, let's say picking a corner. We're doing our bores, we're drilling, we're doing our tang cut for the main bearing, and that's done. I'm also setting it in there, not in a floating fixture, but where I'm indicating this side of the cap and this side of the cap, and kind of massaging it down so that it's level, because it was machined perfectly this way in a horizontal fashion. Now we're standing it up and we're drilling and doing all the machine process there. So that was real critical to make sure it's flat. We don't want it to be crooked. So took care of that. Within about 8/10, so under 1 thou, on average throughout all of them. So pretty happy with that. And again, we are pinning them. Now, I have the capability of a 4th axis. I can put this block in there. Do I want to know if I can come up with a solution not to be able to do that? This numbered cap works great. I'm going to bring the camera in. At first, I'm going to show you the fixture that I made. Get it off here. Okay, it's nothing crazy. This is the fixture. Okay, these are 201 drill guides. Okay, number 7 drill bit, and I tapped it crudely, 3/8 tap, to be able to slide hammer it out. Now, it is basically modeled off the cap, just a negative. Okay, that's basically what it is. And with the block, all I'm doing is, since this is correct and this is correct, I'm setting this into the block without any studs on there. Okay, in theory it worked, it should work, and it did work. Okay, I'm carefully tapping this in. I did beat it up a little bit, but it doesn't matter. I was trying to think of creative ways to get it back out without damaging the block. But ultimately, I had a vice grip slide hammer, didn't work. So I drilled and tapped it while it was still on the block, carefully. This sits into the register of the block, and then we hand drill with the drill guides, the 201 drill bit, down. We're actually, the pin is 400 thou, we're 200 thou into the cap, and we're relieved, I think it's like 230 or 240 into the block. So that was done. I'll bring the camera in to kind of show you what that looks like, but it's just 2 holes in the main webbing. All right, we got our caps in here. You'll notice, like, in my confusion of machining, the holes don't matter and the bores for the pinning the block, but I had to make a couple alterations. You can see number 5 is backwards, but it's fine. I'm just going to grind that off and change the arrow on my laser. All these caps do not have pins yet. I'm still machining them. This one does. Again, as you see here, we have our pins. Okay, and you can see down here in between the studs, we have our holes there. And it lines up perfectly. And like anything else, it's just nice and careful installing this without beating the cap up or beating the block up. And this is a lot easier with 2 hands. And we have to be very careful. I kind of like to, it should in theory go down by hand. And make sure that cap is not crooked and it's over the pin. We're just going to gently set the cap in. It looks good. Get a good metallic hit. Seems reasonable to me. We have perfect fitment. Again, the main webbing on these blocks, this is an LC9 block. The main webbing is approximately 920 thou wide. So that's what I stuck with. The thrust cap is a little bit different. But ultimately, the majority of the area that they have, there's actually a little bit thicker outer webbing on the thrust on this block. And you can see right in here. But generally the thrust ultimately is wider overall than the rest of these as it protrudes closer to the center. But generally what I'll be doing with my fixture is I'll be doing the 4 cap, the 2 cap. The 5 cap, I'm just going to put it back on my machine to take off this section of the material here, because there are little protrusions on the block that won't allow this to saddle the main web. And I believe the number 1 is also going to be different with these bosses here for the oiling and oil pump mount. And then lastly, once we do that, we come over here and we evenly take it off on those sides, still having our very tight tolerance fit up here, which is critical for that. But again, the cool idea with this fixture is it is modeled off of a main cap, so we know it works because this is sitting in there and it's completely flush and everything lines up real nice with the tang and everything else. So I'm more than confident that that's fine. Once we get this process done, then we can move on to getting the align hone done. Yes, so then we can move on to the align hone, and then once that's done, the next step for me is going to be boring the cam tunnel. With the LS, the cam and the main share the feed. If you look into your LS, you'll see that the oil feed intersects or kind of sidesteps the cam bore there, and it goes straight to the middle of the main tunnel here. We're gonna be boring it out to a certain dimension for a 55 millimeter roller bearing. LSs have a 55 millimeter cam core, so we're going to be boring that out and to be able to put those needle bearings in, completely blocking off the OEM oil feed to the cam bearings because we no longer need it. The needle bearings rely on splash, oil splash. They don't need direct oil feed. The design of the bearing cartridge, the cage or housing, excuse me, there's no holes around it, and you not need to put one in there. So once we press them in, we're now blocking off oil that would feed a normal Babbitt style cam bearing, and the cam needle roller bearings are going to rely on oil splash as the crank is spinning around, and oil splash falling out of the lifters and the heads rolling back into the windage of the crank here. So we're going to be improving oil efficiency by eliminating that style. That is a little tedious, but I'm actually bought some specific cheaper carbide cutters, and I have a standard hardened boring shaft that I'm going to be modifying to fit in here. That's going to be on another video of this engine. So that'll be another portion of this engine build series. Is doing the cam tunnel. Not so exciting, but I think if you have the capability like I do, now I don't have crazy machines. I have a 3-axis CNC with a 4th axis, and I have a CNC lathe, and I have other vertical CNC machines. This happens to be a VF5 where the work is going to be done on that. Not the cam bore tunnel itself. That's going to be done in more of a manual sense. As of right now, because I don't have a right angle 90-degree head, I'm not doing any of that stuff. I can confidently achieve that more or less with a mounting plate up here and bearing guides on the outside. So I think, but when I get to that point, I'm not there yet. I will be filming that and having that as another series on this, as well as simple as this is going to, once it's line board, we're going to go into the 4th axis. And we are going to deck this block, and we are going to machine grooves in it for a fire hoop. We are going to be pushing quite a bit of power through this, so we want to make sure that we're not going to be lifting ahead, having really good positive sealing on the head gasket. So that's the plan. But really happy with the way this turned out. This block was very lightly driven. I assume it really didn't have any. Everything looks great. Checked everything overall. This came out of a running and driving 90-something thousand mile 2013 2-wheel drive pickup truck, Chevy. So it really is a fantastic platform base to kind of work off of. Again, if you don't know, it's an LC9 block, and it has really thick cylinder sleeves. We're going to be honing this out 5 thou to step up 5 thou from the standard bore of 3-inch 780 thou to 3-inch 785 thou. We should have enough. Everything in reality checks out from putting it on my granite table and indicating and checking to make sure the cylinders are where they're kind of close to need to be. And we're well within a couple thou with how this is. Pretty surprised. And our deck is, I think, 9-inch 243, I think. So we're good there. We have enough to kind of take off. We're going to be taking off a little bit lower because the deck is a little bit shifted from left to right. So we want to make sure that we have consistent deck surfaces. But I'm going to be doing all that here. I am not an engine builder. I am a CNC machinist. And hopefully I don't screw this up too badly that I can't fix it, because I don't want to buy another block. I got a really good deal on this complete engine, so just taking my time and making sure. We are officially rolling up to almost about less than 3 months, and probably 2.5 months till I have to be ready. As you can see, the truck is nowhere near there, but we actually have a schedule now where we got my co-driver and our team being like my dad and other people to help, to get this to a roller, which is pretty soon. Yes, I don't have front suspension for it. It is sitting over there. Just haven't really got to that point of finalizing that front suspension. Again, I'm going to have a huge video out about the progress in that, but I want to get it to a point where it makes sense. You're not looking at like, what the hell is this? So a few more things we're going to do on that, but I'm real excited that we're getting that wrapped up. Hopefully we're not testing on test day for the first time. Hopefully looks like we'll be about a week and a half out. So beginning of September, we'll be going to the closest track that we have here and be testing. So I hope we make the deadline, because I also have to get my license, my 990 license, 10.0 and quicker, to be able to race this event at Hot Rod Drag Week 2025. In all honesty, if it doesn't happen, I really don't care. I want to race it. This is a nice kind of event to roll out with. This is just a designated drag and drive truck, so I'm not looking to do any other competition racing. So I'm building it the way I want it, and to be safe. So check back again. This is going to be as part of a build series and of the machine work on this LS and making all these custom parts to save money, and to also try it myself and see how it works. Thanks again for watching. If you're new here, please consider subscribing, comment, like the video, share it. Really helps. It helps grow the channel. I know I haven't posted a lot. I'm trying not to make it a career. Just trying to get good content out for everybody. But you'll be seeing more of this LS build. That's unconventional in my opinion, just because we're doing aluminum caps and we're going to be boring the cam tunnel. And you'll see the benefits of that too. If you decide to do it yourself, pay somebody to do it. But hopefully I'm doing everything the way it needs to be done. And I do have help from experienced engine builders too that are kind of coaching me as I go along. So thanks again, and check back for the machining on the cam tunnel. It should be the next video. Take care.